Hello and welcome. In this video, we're going to define what the unit circle is, how to find the different angles on the unit circle in degrees and in radians, how to use reference angles with those different angles on the unit circle, how to find the coordinates on the unit circle, and how to use the coordinates in relationship to trig functions. So we're really going to start at ground zero with what is the unit circle, how do we find the different pieces of it, and then we're going to extend that idea into how do we use it once we know how to create it. So let's go ahead and jump right in. All right, so in the last section, we talked about creating an angle by rotating an initial side some degree theta around in a circular motion and how that creates an angle and a reference angle. What we're going to do now is talk about what if we limit exactly how we're looking at that. What if we look at a circle whose radius is 1? Then if we rotate it around, we could still create a triangle with the x-axis and look at our x and our y. But now if we use that reference angle to find sine, cosine, and tangent, we actually have a radius value that is 1, which means that sine of theta is going to be y over r, or in this case, y over 1, which means that sine of theta is just y, which actually means on the unit circle, which is going to be the circle centered at 0, 0 with radius 1, that's how we are defining the unit circle. In terms of the unit circle, every y coordinate is going to be the same thing as sine of that angle, since the radius is 1 and sine is y over r within a circle. Similarly, for cosine, cosine would be our x value adjacent over our hypotenuse, which is 1. So cosine of theta is going to be x over 1, or just x, which means within the unit circle, every single coordinate is of the form cosine theta comma sine theta. So that's going to come into play a little bit later. So what we're going to do now is we're actually going to talk about radians and degrees on the unit circle. And the idea is we know specific things about 30, 60, 90 triangles and about 45, 45, 90 triangles that are going to be true all the way around this unit circle. And you're going to see how that ties in a little bit later. But if you have highlighters, this is going to be a great time to grab them. We're going to talk about first filling in the degrees on a unit circle. So we know we start on the positive x side at the angle 0 degrees. If we rotate in the positive direction, meaning counterclockwise, halfway around the circle, we know that halfway around a circle is 180 degrees and back around is 360 degrees. If we cut that in half, if we just go exactly a right angle amount, we've rotated 90 degrees, which means between 180 and 360, halfway between those two would be 90 more degrees, which is 270 degrees. So really I'm saying 0 plus 90 is 90, plus 90 is 180, plus 90 is 270, plus 90 is 360. That's all the way around. But what happens if we break each of those angles in half? So halfway, this angle here would be halfway between 0 and 90 degrees, which is 45 degrees. Halfway between 90 and 180 would be 45 more degrees. So if I'm at 90 degrees and I add 45 more, this angle is going to be 135 degrees. If I add 45 again, I get to 180. If I add 45 to 180, or halfway between 180 and 270, I'm going to get 225 degrees. If halfway between 270 and 360, so if I add 45 more, 270 plus 45, I'm going to get 315 degrees. And you don't necessarily need to show the work off to the side, but I just want you to see we started with just looking from 0 to 180, then we split those in half. Now we're splitting our halves in half, so we're looking at 45 degree angles. What if instead of looking at 45 degree angles, we actually started looking at breaking our 90 up into 3 pieces? So if we break 90 into 3 pieces, how many pieces? Each of those are going to be 30 degrees. So I'm going to highlight these all the way around, and we're going to be looking at these 30 degree angles. So I'm going to start at 30 degrees. If I go up to the next red piece here, I'm adding 30. So that's going to be 60 degrees. If I go up to the next red piece, I'm going to be at 90. And then I'm going to keep rotating around. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180, which we already have. If I add 30 to that, I get 210, 30 more, 240, 30 more, 270, which we already have. 30 more, 300, 30 more, 330. If I add it again, I get back around to 360. So these are the angles that we need to be able to use on the unit circle. They have special coordinates that we're going to derive later in this video, but really just start by labeling the ones you know and then cutting it into pieces so that we can identify using our 30-degree angles, using our 45-degree angles. We're really just adding as we go around. And I really like to use color when I do this. It makes it easier for me to see, am I adding 30, am I adding 45, and so forth. Now radians, which we're really trying to build that comfort with, we're gonna do it in the same way, but we're gonna be writing our angles in terms of radians. So we learned in the last section that we start with 0 radians, halfway around the circle is pi radians, all the way around the circle is 2 pi radians. So if I cut that in half, how many radians have I gone? Between 0 and pi, if I cut that in half, half of pi is pi over 2. So if I think about this as halves of the circle, this is pi over 2, 1 pi over 2. This is 2 pi over 2, which is pi. This is going to be 3 pi over 2, and this is going to be 4 pi over 2, and 4 pi over 2 is just 2. So this is 3 pi over 2. Now, if I cut each of those halves in halves, just like I did with degrees, now I'm going to be looking at 4 pieces of pi on the top and 4 pieces of pi on the bottom. That's why, so I want you to see this is one piece. Actually, let's just label them. This is 1, 2, 3, 4 pieces of pi. 5, 6, 7, 8 pieces of pi. So if I think about these as angles, this is 1 pi over 4. This one would be 2 pi over 4. We already have a number there, so that must be the simplified version of what we're saying. That means this angle over here is going to be 3 pi over 4. This is going to be 4 pi over 4, which is just pi. Keep going around. This is going to be 5 pi over 4. This would be 6 pi over 4, which we already have, the simplified version of that. That makes this angle 7 pi over 4, and this one 8 pi over 4, but we already have the simplified version of that. So we started by just looking at the quadrants, then we cut each of the quadrants in half, just like we did with degrees, to look at our different pi over 4s. Now, you guessed it, we're going to look at now in red, cutting each of those pieces into 30-degree angles, or in this sense, into pi over 6. So let's see if I just cut, ignoring those blue lines that are on the in-between, the pi over 4s we just found. Now I want you to count how many pieces of pi do we have in the top. So we have 1, 2, 3, 4, 5, 6 pieces of pi. That means each individual line is 1 pi over 6. That means this one would be 2 pi over 6, and that we can actually simplify. That's going to be pi over 3. That means this would be 3 pi over 6, which is the same thing as pi over 2. This one is going to be 4 pi over 6, which we can simplify, 2 pi over 3. This one is going to be 5 pi over 6. This one is going to be 6 pi over 6, which is just pi. Now down here, 7 pi over 6, 8 pi over 6, which I need to simplify this. I can divide those both by 2. This would be 9 pi over 6, but we already have it simplified. That makes this one 10 pi over 6, which we should simplify. And this last one, 11 pi over 6, because then we would get to 12 pi over 6, which is just 2 pi. So you may want to go back, rewind, watch that part again, but don't worry, we will fill in another complete unit circle towards the end of this video. The more you practice this, the easier it is. But really start with the quadrants, then move to the 45-degree angles, or the pi over 4 angles, then move to the 30-degree angles, or the pi over 6 angles. Now that we've talked about graphing radians, let's talk about reference angles and review that in terms of both angles in degrees and angles in radians before we move into graphing or identifying the points on the unit circle. All right, so we already talked about in the last video how a reference angle, theta, is an acute angle formed using the terminal side and the x-axis. So it's always going to be a positive angle formed with the x-axis. We're going to be able to use the unit circle to help us figure out a lot of different trig function values with reference angles. So we need to be able to graph and identify them. So if we're graphing 5 pi over 3, what that means is we're cutting from 0 to pi, we're cutting that into 3 pieces. So this would be pi over 3, this would be 2 pi over 3, and here would be 3 pi over 3. So let's cut the bottom into pieces as well. 4 pi over 3, 5 pi over 3. So what we're saying is the angle that we're talking about, 5 pi over 3, is here. Theta equals 5 pi over 3. The reference angle is going to be this angle here. How many more pi over 3s do I need to get to the axes? I need 1 pi over 3. So the reference angle is going to be pi over 3. Why don't you go ahead and try and work through 2, 3, and 4. For number 4, you're going to be cutting your pieces of pi, the top half into 4 pieces and the bottom half into 4 pieces. So go ahead and try those 3 and then unpause the video and see how you did. All right, for number 2, 150 degrees in the negative direction means we're rotating clockwise, which means our reference angle is going to be how much further we need to go? 30 degrees. It's going to be our reference angle. 4, I'm going to come back to number 3. For number 4, we also, again, need to go 30 more degrees to get to the x-axis, positive angle with the x-axis. For number 3, I started by cutting this into fourths, so I can see this is 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in order to get the angle that I'm talking about, I'm going to end here, but I'm going to go all the way around to get there. So my reference angle to get back to this axis is going to be pi over 4. That's how many more pi over 4s I need to get back to the x-axis. So now that we've talked about reference angles, we're going to use that and what we know about special right triangles to identify the coordinates that correspond to the angles we just identified on the unit circle. Okay, so if we think about the points on the unit circle, and I'm actually going to add a few more here. Let's first identify the points that are on the axes. If this circle has a radius of 1, that means this coordinate right here is the point 1, 0. What does that make this coordinate up here? Well, if the radius is 1, that's the point. X, Y is 0, 1. This coordinate over here is going to be negative 1, 0. And this coordinate down here is going to be 0, negative 1. Now, if we want to cut those in half, as we did before, to talk about our 45-degree angles, let's actually go ahead and look at this as a right triangle. So I'm going to erase this one here because that's going to be confusing. So if we look at this 45-degree angle, we know that the radius is 1 because this is a unit circle. Every single radii in this circle has a length of 1. We also know that with a special right triangle, the lengths of each side are the same. And to find the hypotenuse, we multiply the length of one side by the square root of 2. That's what we know about special right triangles. Both sides are the same for a 45, 45, 90 triangle, and to find the hypotenuse, we multiply the side by root 2. What that means is if the hypotenuse is 1, 1 is equal to x times the square root of 2, which means that x is equal to 1 divided by the square root of 2, and we're going to go ahead and rationalize that denominator. So that's going to tell me that x is equal to root 2 over 2. So this length here is root 2 over 2. Now, 45, 45, 90 triangles are isosceles. That means that the y value of this coordinate is also going to be root 2 over 2. So if I were to write this as an ordered pair, I'm going to have root 2 over 2 and root 2 over 2. Now, if I want to look at the same point in the second quadrant, I could draw this angle, and instead of looking at this whole angle here, I could use reference angles, and I could look at this 45-degree angle as my reference angle to find the different values. Well, we just did this math. We just figured out the side lengths of this triangle. I want you to ask yourself, what's going to be different about these lengths if we're looking at this triangle in the second quadrant? What's going to be different? Hopefully you realize the x value, if we're just thinking about points in a regular xy coordinate plane, the x value is going to be negative in this quadrant. The y value is going to be exactly the same. So what I want you to notice is that this coordinate is exactly the same as it was in the first quadrant, except the x value of the coordinate is going to be negative. What is that going to mean about this coordinate? Hopefully, what you realized is that we could draw another 45, 45, 90, but now both x and y are going to be negative because think of where we are in the coordinate plane. We're in the third quadrant, which means both x and y are negative. So this is going to be negative root 2 over 2, negative root 2 over 2. What about in the fourth quadrant? Again, reference angles would tell us we could use this 45-degree angle, still radius 1. So the only difference down here is that x is positive here and y is negative. And again, you're just thinking about this as if it were any ordered pair in any quadrant. We know that everything in the first quadrant is positive. In the second quadrant, our x's are negative and our y's are positive. In the third quadrant, everything's negative. And in the fourth quadrant, x is positive and y is negative. So really, we need to know the points that are on the quadrants, and we need to know that the 45, 45, 90, the coordinate that corresponds to that angle is root 2 over 2, comma, root 2 over 2, and then we can just reflect that or adjust the sign to put it in its appropriate place, whether it's here, here, or here. So let's use that same rationale to figure out how we could identify the other points that we drew when we were looking at degrees and radians. We looked at 30-degree angles, and then we also had a 60-degree angle. Okay, so let's focus on this angle right here. So I'm going to draw a triangle. This was our 30-degree angle. We know still the hypotenuse is the radius, which is 1. So we can use special right triangles to find the other lengths. Remember, in a special right triangle, the shorter side, so 30 degrees is across from the shorter side, which I'm going to call, actually I'm just going to call it S for side. The hypotenuse is 2 times the length of that side, and the angle or the segment across from the 60-degree angle, the side across from the 60-degree angle, is the original side, the shorter side, times the square root of 3. So let's think about what we know. In this triangle, we know that 2 times the smaller side is 1 because the hypotenuse of our triangle is 1. So that tells us that the shorter side, in this case y, is going to be 1/2. So the y coordinate of our point would be 1/2. The longer side is the side that we just found, 1/2, times the square root of 3, which means we're looking at the square root of 3 over 2. That's the length of the longer side. Now, thinking about where this point would be in this quadrant, we could draw the exact same triangle. This would still be 30 degrees. The radius is still 1, so how is this point that we just found going to be modified if it reflects over here or if it's in this quadrant? If we're using this 30-degree reference angle, how does that determine the coordinates of this point? Well, hopefully you're realizing that's just going to make the x part of the coordinate negative. The y part will stay positive. What if I reflected it down here? Still a 30-degree reference angle, but now in a different quadrant. Down here, everything is going to be negative. And then the last one over here, the x value will be positive and the y value will be negative. Okay, now let's take a look at the 60-degree triangle. So if I draw a triangle, don't worry, I'll bring it down as well. If I draw this angle, which is 60 degrees, I'm going to go ahead and redraw that down here, 60 degrees. We know the radius is 1. This is really just going to be almost exactly like what we just did, except now this is going to be side root 3 and this is going to be side. Well, we already did all this math over here. The side we said was 1/2. So the x part of this coordinate is going to be 1/2. The y part of this coordinate is going to be root 3 over 2 because 1/2 times root 3. How is that point going to be different if you take that point and you draw a different triangle over here? Reference angles will be using the same 60-degree angle, so the only difference is that our x value is going to be negative and our y value is going to be positive. Down here, they're both going to be negative, so negative 1/2, negative root 3 over 2. Down here, x is going to be positive and the y coordinate is going to be negative. We still know the points on the axes. This is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. So let's actually fill in a blank unit circle, start to finish, with all of the radians and all of the degrees. So looking at a blank unit circle might be really daunting. So I want to practice walking through each part, putting them all together here. What I want you to notice is that this unit circle is showing you, this little symbol is saying put your degrees in here. That means we're going to put our radians in here and we're going to put the ordered pairs on the outside. When I do a unit circle, I like to start with dealing with the degrees first. So I'm going to do that in red. I'm going to start at 0. I know that halfway is 90. I know that the first quadrant is at 90. I know that this would give me 180 degrees. Down here would be 270 degrees. All the way around would be 360 degrees. Now I'm going to go through and I'm going to fill in my 45-degree angles. I'm going to do that in green. So 45 degrees, if I add 45, I get 90. If I add 45, I get 135. Remember, I'm cutting each quadrant in half now. If I add 45, I get 180 plus 45, so halfway between 180 and 270. That's going to give me 180 plus 45, 215. Plus 45 is 270. Plus 45 is 315. And then I get back to 360. Now I'm going to go with my 30-degree angles. I'm going to do that in blue. 30 degrees, 60 degrees, 90, then 120, 150, then 180, which is already there. Then 210, 240, 270, which is already there. 270 plus 30 is 300. 300 plus 30 is 330, and then I'm back around at 360. Now I'm going to do the exact same thing with radians. I start at 0 radians. Halfway around is pi, all the way around is 2 pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Now I'm going to do my 45s. Halfway between, right, if I'm looking at, I'm going to try and mark this up, breaking this into 4 pieces here and then breaking the bottom into 4 pieces. This is pi over 4, which makes this 2 pi over 4, which we already have, which makes the next one 3 pi over 4, which makes the next one 4 pi over 4, which we already have. That makes this 5 pi over 4 and 6 pi over 4, which we already have simplified. That makes this 7 pi over 4 and 8 pi over 4, which is the same thing as 2 pi. Now I'm going to look at breaking it into 6 pieces, just like we did with 30 degrees. So I'm going to be looking at not at those middle lines. Let me fix this. That's better. So I'm going to be looking at my 30-degree angles, or each spot. How many does that give me? That gives me 1, 2, 3, 4, 5, 6. So I have 6 pieces of pi now. So the first piece is pi over 6. The second piece is 2 pi over 6, but that's going to just simplify to be pi over 3. Then 3 pi over 6, but we already have a number there, so we already have the simplified version of that. Then we're going to have 4 pi over 6, which I'm going to simplify, is going to be 2 pi over 3, because 4 and 6 are both even. That's going to give me 5 pi over 6, 6 pi over 6. We already have that, though. That's going to make this 7 pi over 6, which makes this one 8 pi over 6, which simplifies to 4 pi over 3. 9 pi over 6, which we already have a number written here. So this next one is going to be 10 pi over 6. Simplify that fraction, 5 pi over 3. 11 pi over 6, and then back around to 12 pi over 6, which is 2 pi. So now I've done all the degrees and all the radians. I'm going to go back through and I'm going to add in the coordinates. So this point, radius is 1. We haven't rotated at all, so we're looking at x being 1 and y being 0. Up here, x is 0, y is 1. X is -1, y is 0, x is 0, y is -1. Looking at those 45-degree points, so thinking about those 45, 45, 90 triangles, we have root 2 over 2, root 2 over 2. In this quadrant, the first one is negative. Down here, they're both negative. In the last quadrant, the first one is positive and the second one is negative. Now let's look at those 30, 60, 90 triangles. Root 3 over 2 and 1/2, and if we reflect that over to the other side, negative root 3 over 2, positive 1/2, and if we reflect it down, both of them are negative. And if we reflect it back over, x is positive and y is negative. And then our last point, we're just flipping that. If we reflect it over here, x is negative. If we reflect it down, they're both negative. And in this last quadrant, x is positive and y is negative. And that's a fully filled in unit circle. So practice doing this so that you can use it. So let's talk about now, how can we use this unit circle? Just for a little bit, and then I'm actually going to make a second video that ties this all together a little bit more. So I'm going to make this smaller, and I'm going to pull in the last examples on this page. So one of the things that we talked about at the beginning of this video is that every coordinate on the unit circle can be written in the form cosine theta, comma, sine theta. And that comes from the fact that the radius is 1 and sine is y over radius and cosine is x over radius. Well, how does that help us? Well, if we know a coordinate on the unit circle, that means we actually know cosine and sine. So for example, this point right here, cosine of theta is 1 and sine of theta is 0. We know that because these two things have to go together. 1 is equal to cosine of theta, 0 is equal to sine of theta. Similarly, for this point, we know that cosine of theta is root 3 over 2 and sine of theta is 1/2. So we can use that to actually help us identify all 6 trig functions. So we're going to use 2 important facts. We're going to use the first, that cosine theta, comma, sine theta is every point on the unit circle. The second one we're going to use is that tangent of theta is sine of theta over cosine of theta, which should make sense. If this is x and this is y, we know that tangent is going to be opposite over adjacent, which is in this case going to be y over x. So we're going to use these 2 very important pieces of information to actually complete this table below. And the reason we're completing this table below is I just want you to see how using a coordinate on the unit circle can actually help us identify any trig function at those specific angles. So the 45, 45, 90 point, that coordinate is root 2 over 2 times root 2 over 2. That means that root 2 over 2 is cosine because cosine is the x coordinate. It also means that root 2 over root 2 is sine because sine is the y coordinate. According to this formula here, tangent is sine divided by cosine. What do I get if I divide something by itself? I get 1. How do I find cosecant? I just take the reciprocal of sine. So that's going to be 2 over root 2, which I'm going to rationalize. So I'm going to multiply by root 2 over root 2. This is actually just going to simplify to be 2 root 2. I'm going to do this off to the side. 2 root 2 over 2, which is just 2. Notice the exact same thing is going to happen with secant, right? We're going to reciprocate 2 over root 2. So the reciprocal of secant is also just going to be root 2. Sorry, I wrote 2, but I meant root 2. The reciprocal of tangent is cotangent. In this case, that's still just going to be 1. So simply by knowing that the 45-degree angle point is root 2 over 2, root 2 over 2, we could find sine, cosine, tangent, and then therefore we could find their reciprocal functions. What's the 30-degree point? The 30-degree point, is root 3 over 2, comma 1/2. That means root 3 over 2 is cosine, 1/2 is sine. So tangent, and I'm going to do this off to the side also, tangent is sine divided by cosine. So if I reciprocate and multiply, I'm going to get 1 over root 3, which I'm going to go ahead and rationalize. 1 over root 3 is the same thing as root 3 over 3. Now I can find the inverses. So the reciprocal of 1/2 is 2. The reciprocal of root 3 over 2 is going to be 2 over root 3. And if I rationalize that denominator, 2 root 3 over 3. The reciprocal of root 3 over 3, or the reciprocal of 1 over root 3, is going to be root 3. All right, last but not least, our 60-degree coordinate is 1/2 and root 3 over 2, which means that cosine is 1/2 and sine is root 3 over 2. So we're just really switching everything that we just did here. So tangent is root 3 over 2 divided by 1/2, which is going to be root 3, which means cotangent is going to be the reciprocal of that, but we need to rationalize. The reciprocal of sine to get cosecant is going to be 2 root 3 over 3, and the reciprocal of cosine to get secant is going to be 2. So there was a lot going on in this video. What we did was we talked about what the unit circle is and how to identify degrees and radians on the unit circle. We then used special right triangles to determine the coordinates on the unit circle, and we practiced running through start to finish how do you fill in a unit circle. Lastly, we just dipped our toes into the idea of if we know a coordinate on the unit circle, how we can use that coordinate to find the 6 trig functions, which we're going to build on even more in the next video. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.